welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I am glad you joined me this evening. Tonight's homework is for the evening of March 26, 2018, and we're looking at the benchmark review. Let's go ahead and get started. Now, even though we have had our last benchmark for the year, I think, what we're going to do from now until the SOL is have SOL style reviews. So think of tonight as prep for the SOL, because I know earlier today you all took your last benchmark for 2017-2018. So let's go ahead and get started. So the first question here is about the Pythagorean theorem. And the question asks us, which of the following is not a way to verify the Pythagorean theorem? And here we have our diagram. Here's our a squared, here's b squared, here's c squared. Now remember, the Pythagorean theorem is always a squared, which is represented by this square, plus b squared, which is represented by this squared. If you put them both together, they add up to be c squared. So let's go through these. Our strategy is to treat them like they're true-false questions. So with the first one, is block 1 plus block 2 equal to block 3? Well, in terms of the Pythagorean theorem, we're asking, is b squared plus a squared equal to c squared? And it is. That all we did was flip a squared plus b squared. So yes, this one is true. So let's go to the next one. Is block 3 minus block 1 block 2? So we start with our theorem, and can we rearrange it to sort of look like these representations? And yes, we can. A squared, which we're calling block 2, is equal to block 3 c squared minus b squared, which is block 1. So this one is also true. Number 3, here's choice C, is block 2 minus block 1 equal to block 3? So is a squared minus b squared equal to c squared? And that answer is absolutely not. That's the opposite. I don't know what this is. This is some imaginary type stuff here. But yeah, C is definitely wrong. And just to make sure, let's check D. Can we rearrange the theorem to look like this? Well, is block 3 minus block 2 equal to block 1? Well, we're saying is c squared minus a squared equal to b squared, and it is. So the answer here is C. The answer is C. And all we're doing is rearranging the Pythagorean theorem, and the one that does not fit is C. All right, moving on. The overall height of a monument is 41 feet, and if a scale model of the monument is created using a scale of 5 feet, being equal to 2 inches, what is the height of the model? Well, the statue in question is this one. It's of Robert E. Lee and his horse, Traveler. And the scale ratio is always stated in inches per feet, and the monument that we're building is inches per feet. So the scale ratio is that for every 2 inches in our toy model, or in our representation of the statue, it represents 5 feet in real life. So that's where those lines come from. Now, if we know that we have 41 feet in our statue, how many inches tall should our model be? That's the question this thing is asking. So let's fill in the blanks. For every 2 inches, we have 5 feet. So that's 2 over 5 equal to x, the number of inches our model should be, over 41 feet. So we're really creating a proportion. And once we get to this point, this is the hardest part of the problem, is setting it up. Once you get here, you just cross multiply, divide, and you're done. So let's do that. So the first thing we do is 2 times 41, and that's cross multiplying, equals 5 times x. And 2 times 41 is 82, equal to 5x. Divide both sides by 5, and you end up with 16.4 inches equals x. So that tells us that our model should be 16.4 inches tall. So the answer is going to be G. All right, moving on. What type of transformation did a student use to create the logo? Now remember, if you guys are reading out of the book, what I'm actually doing is paraphrasing the questions. So if you have your book and you're reading along, what I'm doing is telling you what the question is actually asking you. So what type of transformation is this? And again, we haven't gone through transformations, but it's easy. So we start with this lightning bolt. Then we rotate this lightning bolt, rotate it again, and then we rotate it one last time to create our final logo. What word did I keep using? Rotation. The answer is C. We just keep moving it around. All right. Now, number 4. Curtis leans a 26-foot long ladder against the wall. The base is 10 feet away from the wall. How high up the wall does the ladder reach? The challenging part of this question is to figure out exactly which side of this triangle we're looking for. It is a right triangle. So the ladder is 26 feet long and it's leaning against the wall. So the ladder part is C. That's that green line. The base is 10 feet away from the wall. That's the base of the ladder. So that's B. That's that red line. What we're looking for is a leg, not the hypotenuse. Usually when students get this wrong, it's because they automatically think, okay, we're looking for a hypotenuse. And as a matter of fact, that was something that I had to be careful about. And with me, it was always rushing. I look at a problem like this and just figure, oh, well, it's got to be the hypotenuse they're looking for. Not all the time. So let's go ahead and fill in our blanks with the Pythagorean theorem. We have A, which we don't know, B is 10, and C is 26. Remember, your hypotenuse is always the largest measurement in your right triangle. So A squared plus B squared equals C squared. A squared plus 10 squared equals 26 squared. 10 squared is 100. 26 squared is 676. Then you subtract 100 from both sides, and we have A squared equals 576. Take the square root of both sides. A is 24 feet. And yes, I did move through that problem 2 steps at a time because this is a review at this point. All right, so A is 24 feet. Now, that means the answer is F. All right, going on to the last one. When a shadow moves across a sundial, what type of transformation best describes the change that happens between sunrise and sunset? Okay, let me tell you what this is. A sundial, and you guys might have read about this in your history classes, basically is a stone that is sitting up tall enough to cast a shadow. So here's the sun. Here's our sundial. The sun rises in the east. You see that blue arrow? That represents the shadow that triangular stone is casting. So in the morning, the shadow is pointing west. But by the evening, when the sun has moved across the sky, that same shadow is pointing east. Now, what kind of changes occurred? Look just at those 2 arrows. What does that look like to you? If it wasn't a sundial, could it be a mirror? It sure could. So we're looking at a reflection. And this is a reflection specifically across the y-axis. All right? And again, we will talk about that next 9 weeks. So the answer is B. And that's it. Y'all take care. And remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.